Discussing about analytical functions. So analytical functions can also be called as OLAP functions. OLAP, online analytical processing. See, especially all these analytical functions are brought from data warehousing. That is why the name OLAP functions. Analytical functions are first introduced in Oracle 8i. From the version 8i, the analytical functions are available. Not all the analytical functions, few of them were introduced in 8i, few more in 9i, few more in 10g, and the first and last are introduced in 11g. So till Oracle version 11g, we have all these 10 analytical functions. We have rank, dense rank, row number, count, lag, lead, first value, first and last. These are the analytical functions available till the version Oracle 11g. So actually analytical functions started implementing in the version 8i itself. So from 8i till 11g they have introduced many in between. So totally when it comes to the 11g, all these 10 analytical functions are available to us. Now, how these analytical functions are different from the regular functions? So we do have aggregate functions like group functions, max, min, count, sum, average, distinct, etc. When we have the aggregate functions, what is the necessity of going for analytical functions? See, we have row underscore number as an analytical function. We have row number as a pseudo column. We will see the differences between aggregate functions and analytical functions one by one in detail in this session. Let us start with rank. Rank and dense rank, they are similar but not same. See, we can apply the analytical functions within a single group. Within the group, we can apply the analytical functions. In each group, means analytical functions will work either for the entire group or even for individual groups. But when we talk about aggregate functions, it will work for entire. So when we say sum, it will do the total of each department or each particular product. But for that product, within that we want to do some arrangement like order by, ascending order or descending order, which is not possible in aggregate functions. The same thing is possible in analytical functions. See, let us take one department. In this department there are 100 employees. Now we wanted to arrange some sequential numbers for the employees in ascending order, maybe based on their salaries or maybe based on their joining date or based on their experience. We need to arrange them in some particular order and assign a number for them, maybe in ascending order or descending order. That is not possible straight away using aggregate functions. So we need to have subqueries over there or inline views over there, maybe 2 times or 3 times to achieve that result. But that is possible through a single query using analytical functions. That is where the analytical functions will come into picture and the performance also will be improved because of analytical functions. The main purpose of analytical function is to improve the performance and to make the queries as simpler as possible. When we use traditional queries for the same purpose, the performance will be huge. That means the response time is more. It will take lot of time. When we use analytical function, it will come within short period of time. See, let us take count. We do have aggregate function of count and we have analytical function of count. We can see practically the difference between using count as an aggregate function, count as an analytical function. We can see the response time in both the cases. Like with clause, how we have seen. The similar way, we can see the difference in response time of count, because this is common in both analytical functions as well as aggregate functions. Similarly, row number, it is not aggregate function, it is pseudo column. So we can see only the difference in case of count, because this is common in both aggregate functions and analytical functions. Here we can see the actual response time in the traditional way and using analytical function. Let us start using one by one. Now let us discuss these functions in detail. Rank. This function will be giving the ranks based on the data or based on the group what we have chosen. It may be in ascending order or in descending order of particular column. If we arrange the data in ascending order based on salary, then it will be assigning the ranks starting from smallest to highest. So it will be giving some numbering, but there is a catch here. When two employees have the same salary, both the employees will be given the same rank. So when we have 100, 200, 200 and 300, 100 will be given the rank 1, 200 and 200 will be given the same rank, which is 2 and 2. The next is 300, 300 will be given the rank as 4. There is a gap, 3 is missing here, because 200 and 200, since one should be 2, one should be 3, but both of them having the same value, both will be given the smallest rank, that is 2 and 3. Among these the smallest one is 2, so both will be given the rank as 2. So 3 will be skipped here, the next number will be given the next rank, that is 4th. 3 will be skipped, 3 will be missing here. That means we will be finding some gaps in the values of rank. To overcome this, we have one more function which is dense underscore rank. Concept is same. For the same example, 100, 200, 200 and 300. 100 will be given the dense rank as 1, 200 and 200 will be given the dense rank as 2 and 2. The next value is 300. In case of rank, 300 will get the rank as 4, but in case of dense rank, the 300 will get the dense rank value of 3 itself. That means we do not find any missing values or any gaps in between the dense ranks. There is no doubt the same values will get the same dense rank, but the numbers will be continuous. There won't be any gap. We don't find any missing values in case of dense rank. So we can see the ranking continuously without any missing values. That is the difference between rank and dense rank. If we do not have any similar or same values, then rank and dense rank will be exactly same. If all the values are distinct, there is no repetition, then rank values and dense rank values will exactly be same. If there are any redundant values, duplicate values, then the rank values and the dense rank values will be different. The dense rank will be continuous without any gaps. Rank will have gaps in between wherever we have the common values. Row number. The row number in analytical function is a physical numbering system. We have row num ROWNUM as a pseudo column, which is the logical number. That is not physical, but row underscore number is the analytical function. Here this values of this row number is physical. So we can assign a physical row number for the groups or within the group. When we assign the physical row number within the group, we can query the data based on the physical number, that is row number. We can use where row number equal to 1, row number equal to 5, row number is less than 6, greater than 7. Every relational operator is allowed with row number analytical function because we are giving physical numbering using row number within the groups. Count. This will give the total number of records within the group or the entire group. This is same as aggregate function, but lot of performance gain will be there when we use this as an analytical function. Lag and lead. Lag will give the previous value, lead will give the next value. From the current position, we can take the previous value as well as the next value from any point, from any position. Suppose if we are in the position 100, we can take the previous value, that is 99. We can take the next value, that is 101. While choosing the previous values and next values, we have an option. So it will take, it has second parameter, one extra parameter. When we are taking the previous value or next value, which position to be considered? By default, the position is 1. That means the immediate next value, the immediate previous value will be displayed when we go with the default value. When we choose the position, suppose the position as 2, then from the current position, the second next value, second previous value will be given. That means when we stay, when the current position is 100 and when we want to take the lead or lag of with position 2, then lag will give the previous value, that is second position from the current position, that is 98. The lead, the next value, second position from the current position, that is 102. So like this, we can choose which position's previous value or which position's next value to be considered using lead and lag. So this number can be 5, fifth previous value, fifth next value, 100, 100th previous value, 100th next value. So that facility is available when we use lead and lag. First value, last value. First value will always give the first value in the group. Last value will be given the last value of the group. But there is a catch here that we will see when we do the practical session, especially in case of last value. So for both the purposes, we can use first value itself. Arrange the data in ascending order, you will get the first value. Arrange the data in descending order, use the same first value function, you will get the last value. Let us see this in practical session. First and last, these are available in 11G. We can use this first and last in our functions. Dense ranks. So while ranking or using rank or dense rank, we can use this first or last. This we can see in our practical sessions. Let us start with our practical session. Start with rank. So we need larger data here to find multiple groups here. That is why we connect to HR schema. Connect to HR. And then describe employees table. There is one employees table in HR schema. It has this many columns with various data types. So here we have employee ID, first name, last name, email, phone number, hire date, job ID, salary, commission percent, manager ID, department ID. Now take the number of employees in each department. Select department ID, comma, count star from employees, group by department ID. This is normal query we are writing. So in each department we have this many records. Maybe we use order by one department ID. Okay, now department number 10 has 1, 20 has 2, 30 has 6, 40 has 1, 50 has 45, 60 has 5, 70 has 1, 80 has 34, and then 90, 3, 100, 6, 110, 2, null, 1 record. Total 12 rows are there. So when we do the grand total of all these, 45, 55, 60, 95, 106, 107 records are there totally in this employees table. Now let us use rank. So when we do rank in each department wise, we use the rank based on the salary column. Select department ID, comma, salary. We are choosing department and salary in each department, and then we are assigning rank over this is the partitioning column what we are using. We are partitioning based on the department ID, means we need grouping based on each department number or department ID. Within that department we are arranging the salary in descending order and then assign the rank. Get the data from employees table. Partition the employees table based on the department ID. Each department ID to be considered as a separate group. In that particular department ID, arrange the data based on the salary in descending order and then arrange the rankings. That means the highest salaries will be on top. We are giving higher rank 1, 2, 3 for starting from highest salaries in each department. And then from employees, group by department and salary. See, department number 10 has only 1, 20 has 2, 30 has 6. So 1, 2, 3, 4, 5, 6. There is no repetition. 40, only 1. 50, this has 45, I think. Yes, 50 is having 45. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No repetition. 13, 14, 15, 16, 17, 18. 19, 20, 1, 2, 3, 4, 5. Only 25? It is 45. We are using rank. It has displayed only 25 here. Okay. 60. 1, 2, 3, 4. 70. 1. 80. 80 is having 34. Yes. 6, 7, 8, 9, 10, 11, 12, 13, 14, up to 23 only. No repetition here also. 90, 2, 100, 6, 110, 2. Did we use distinct here? Partition by department ID, order by salary, descending. How come it is like this? 74 total. Yes, 74 only. Select department ID, comma, salary from employees where department ID equal to 50. We have 45. Order by 2. 22 2 are there, 24 2 are there, 25 so many are there, 26, 27, 28, multiple records are there. But in our result, partition by department ID, order by salary, descending. So it is taking only the distinct values. Duplicate values are not considered here. Okay, now we have the requirement like choose highest 2 salaries from each department or the second highest salary from each department or second lowest salary from each department, the least salary from each department. That is very easy when we use rank analytical function or maybe dense rank analytical function or even using row number analytical function. See, from the same thing, so this is what is our ranking. From this we need to write one query above this level, select star from this one where rank is less than or equal to 2. That means the 2 topmost salaries will be displayed. Why it is topmost? Because we are arranging based on salary in descending order. So 2 highest or topmost salaries will be considered. If it is ascending order, then 2 least salaries will be considered. So since it is less than or equal to 2, the first 2 records from each department, only 2 will be there from each department. If it is having only 1, 1 will be there. Otherwise, if it is 2 or more, then 2 will be there. 20 rows are there. Okay. Now, from this group, we are selecting order by department ID. We are selecting everything. We are not using group by. Since we are using group by here, the duplicates are eliminated. The similar records, since department ID and salary is same, together has displayed only once. If you remove that part, then we can see the actual duplicates. See, when we arrange based on department ID, then we can see, if you see department number 30, not 30, 50, actually we have 45 records. In that, multiple records are duplicated. See, we have the ranks up to 45. We are taking the rank here. We have the ranks up to 45. See, 1 is there, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 11. Both salaries are same, 3,600. 11 and 11 is arranged, assigned. The rank as 11. 12 is missing. The next rank will be 13. Because out of this, one is 11, one is 12. So 12 will be skipped. 14, 15 and 15. 16 is skipping. 17, so many are there. 17, 18, 19, 20. So next is 21. Next 24. Next 26. 28. 31, 33, 36, 41, 43 and then 45. See, now we can see same ranks with skipping ranks in between. Some of the ranks are not present. We can see missing values here. If we use dense rank in this case, then we can see the continuous numbers. The ranks will not be up to 45. Ranks may be up to 24, 25. Let us use that dense rank. The same query, instead of rank, we are using dense rank. We are displaying the rank as well as dense rank, both order by department ID. See, partition by department ID, order by salary. Dense rank, same partition by department ID, order by salary as dense rank. See, we are displaying rank and dense rank together. Up to 30 we don't have any difference, 40 also no difference. From 50, I think from 11, see, in 50 rank is 1, dense rank is 1. Next 2200 and 2200, I think it is in ascending order. Yes, we are doing ascending order, so smallest first, like that. 2200, 2200, rank is assigned 2 and 2, dense rank is also assigned 2 and 2. So for the next value 2400, rank will be having 4, dense rank will have 3 only. The ranking will be continuous in case of dense rank. The ranks will not be continuous in case of normal rank. So we can see some ranks missing here. No missing values in dense rank. So even if we have 100 common values, for all the 100 common values it will assign the same rank. For the next value it will assign the immediate next rank. See here 2 and 2, next is 3, 3 and 3, next is 4. 4, so many are there, and then 5, 6, 7, 8, 9, 10, 11, so many 11s, and then 12. So finally, at last we have dense rank as 25. That means 25 distinct values are there here. But when it comes to the rank, it is 45. There are so many missing values in between. Totally 45 values are there. But since it is assigning same rank for the same values, we can see some gaps here. But in case of dense rank, even though there are same values by multiple times, it is assigning the same rank. But for the next value, it is assigning the immediate next rank in case of dense rank. This is the difference between rank and dense rank. Now let us see the row number. Row number is almost same as continuous numbers, but with little difference. See, we are displaying rank, dense rank, row number over order by salary. We are not doing any partitioning. We are taking the complete table. For the entire table, we are taking the rank, dense rank and row number based on the salary. Consider the salary. Irrespective of the department number, we are doing the salary as the entire group. So total 107 will be there. Yes, 107. See, in case of rank, we will get maximum number of 107. Row number also we will get maximum of 107. Dense rank, we may not get 107 if we have any duplicate values. 2200. It is same 2 and 2. Here it is same 2 and 2. But here 1 is 2, 1 is 3. And then 4 and 5. So it is giving sequential numbering in case of row number. So totally 107 are there. Now we are arranging based on row number. Now it will be sequential 1, 2, 3, 4, 5 up to 107. Here we are arranging based on the rank. We are partitioning based on the department ID, order by salary in ascending order. We are using rank, dense rank, row number, order by rank. See, all these are first ranks.